So next, let's discuss about the y parameters. Now for the y parameters, v1 and v2 are the independent variables. So our currents I1 and I2 are our dependent variables. We have our I1 equal to y11 v1 plus y12 v2. Then our I2 equal to y21 v1 plus y22 v2. Expressing this in matrix form, we have I1, I2, we have the y parameters y11, y12, y21, and y22 times v1 and v2. Now to solve for the admittance parameters, we need to short one port and then apply a source on the other port. If port 2 is shorted, so if port 2 is shorted, meaning our v2 equal to 0. Port 2. So if v2 is equal to 0, looking at equations, we have equation 1 and equation 2, we can solve for y11 and y21. So y11 equal to I1 over v1 and v2 equal to 0. And our y21 is equal to I2 over v1 and v2 equal to 0. So now when we short port 1, our v1 is equal to 0. So we can solve for y12 and y22. So our y12 is equal to I1 over v2 and v1 is equal to 0. And our y22 equal to I2 over v2 and v1 is equal to 0. Now looking at equations 1 and 2, we also have an equivalent circuit for the admittance parameters. So if I1 is equal to y11 v1 plus y12 v2, so if this is for I1 port 1, I11 is equivalent to y11 v1. So this is y11. So the current at this branch, and we have parallel dependent current source. Just a value of y12 v2. Now for I2, this is I2 port 2. I2 is equal to y21 times v1 plus y22 times v2. We have y22 at this branch plus a dependent current source. Just a value of y21 v1. Now figures A and B shows how to solve for the y parameters. So let's have an example. Obtain the y parameters of the following network. So again, first let's label our v1 I1 and v2 I2. Or I1 V1, I2, and V2. Now for Y11 and Y21, or V2 is equal to 0, or our port 2 is shorted. Our Y11 equal to I1 over V1. V2 is equal to 0. For us to get our Y11, we need to get our Y equivalent as seen by port 1. Our YEQ is equivalent to, so we convert these impedances into admittances. We have 1 over 6 plus 1 over 4. We have series with 1 half. Our YEQ, Y equivalent, is just equivalent to 5 over 22 S. Now looking at the equivalent circuit, this is V1, this is I1, this is YEQ. YEQ is just equivalent to I1 over V1, is equivalent to our Y11. So our Y11 is just equal to 5 over 22 S. Now for our Y21 equal to I2 over V1, V2 equals to 0. Now looking at the circuit, our 4 ohm resistor and 6 ohm resistor are connected in parallel. So we can express our I2 in terms of I1. So by CDT, our I2 is equivalent to negative 4 over 10 I1. So this is negative because I2's direction is going to the left. So our I2 is just equivalent to negative 2 over 5 I1. Now using this equation, our I1 just equivalent to 5 over 22 V1. Now substituting I1 to this equation, so we have I2 equal to negative 2 over 5 times 5 over 22 V1. So our I2 over V1 is equal, which is our Y21, equal to negative 1 over 11 S. So next, to solve for Y12 and Y22, we need to short port 1, or our V1 is equal to 0. So for Y12 and Y22, for V1 is equal to 0. Our Y12 equal to I1 over V2, where V1 is equal to 0. This is shorted. We can express I1 in terms of I2 by using CDT. So similar process in getting Y21. So by CDT, our I1 equal to negative 4 over 6 I2 is equal to negative 2 over 3 I2. Applying KVL at the outer loop to this loop, we have 2i1 minus 6i2 plus v2 equal to 0. Now substituting equation, this equation, we have 2i1 minus 6. So our i2 is just equivalent to negative 3 over 2 i1 plus v2 equals to 0. We have 11 i1 plus v2 equal to 0. So our I1 over V2 equal, which is our Y21, equal to negative 1 over 11. Yes. Now lastly, for Y22, have Y2 over V2, V1 equals to 0. So to solve for Y22, you need to get the Y equivalent as seen in part 2. YEQ, we have 1 half plus 1/4 series with 1 over 6. YEQ, 3 over 22, which is equivalent to our I2 over V2, which is our Y22. So our Y parameters, we have 5 over 22, negative 1 over 11, negative 1 over 11, uh, 3 over 22. Now, looking at the Z parameters, so Z parameters, our dependent variables are V1 and V2. Z parameters times I1 and I2. For our Y parameters, our dependent variables are I1 and I2, which is equal to the Y parameters times V1, V2. Now, looking at these equations, we can clearly see that our Y parameters just the inverse of the Z parameters. For our Z parameters, just the inverse of the Y parameters.